Okay, question 6 starts off as a question about polynomials and factor theorem. There's f of x. We have to use the factor theorem to show this is a factor. So that means we have to find the magic x value from the factor to substitute into f of x, get a particular answer, and make a convincing comment that x minus 1 is a factor of it for the 2 marks. Because you've got to use the factor theorem, simply factorising it doesn't get you any marks at all. But that is what you need to do next. In the next part of the question, now we know that x minus 1 is a factor, you use the grid method. You set up a grid with x minus 1. You put appropriate values across the top so that it all multiplies out to give f of x. You've got examples of this in your chapter 2 booklet of using the grid method, or you may use the thing called algebraic division in order to get this, and you'll get x minus 1, write out your full factorisation in that form to get your marks. Hence, that means use what you've just done. Show the equation f of x has exactly one real root and state its value. So you're working with the factorisation you've just got, a little bracket times a big bracket, and we want f of x to equal 0 at this point. That leads to 2 possibilities. That bracket could equal something, or that bracket could equal something, and altogether we want there to be one real root. Now one of these you see leading directly to a real root, so point that out, state its value. You may want to come back to that at the end. But your job then is to show that the other possibility doesn't lead to any more roots. So write down exactly what that possibility is, what has to equal what, and use your theory of the discriminant, b squared minus 1, to prove that there are no more roots after the first one that came from that possibility. Write it up convincingly and you should get 3 marks. Alright, part B is a complete change of tack. I think this is a total re-entry point. I'm not sure we're going to need anything we've done from part A in order to do part B. Though the fact the graph crosses the x-axis at 1, 0 possibly reinforces the fact you found earlier, but no, part B is new. So if you had a bad time on part A, don't let it put you off getting full marks here. First thing we've got to do, we can ignore the sketch for now, because all we've got to do is integrate 3 terms. You've got a rule for integrating powers of x in chapter 7, apply it to 3 terms, and you get 3 marks. There is something on the end that you should not forget, but the marks are mainly for integrating the 3 terms. Hence find the area of the shaded region bounded by the curve and the line AB. So this is the bit they've got shaded. We've done an integral. What we can do is we can put appropriate limits into that integral. You don't need to set up the integral with the limits, because since we've already integrated it, you can start with the square brackets, appropriate limits on it, substitute the limits in and subtract, and you'll get an answer. But that isn't yet the answer to this shaded sliver here. Integration always finds the area between a curve and the x-axis, so that will give you the area of this region down here. But if you then look at those 2 regions together, you've got the area of a triangle, and you can spot the base of the triangle, and you can spot the height of the triangle because you know these coordinates, and you can use a half base times the height for the area of a triangle. So now we've got the area of the triangle, and we've got this lightly shaded area, which is the answer to the integral, and you can do an appropriate thing with those to find out the area of this sliver trapped in between the line and the curve. And there are worked examples of this towards the end of chapter 7, so you can see how it all pans out.